So in the previous video, we learned how to make the quadratic equations into the completing the square form. In this video, we are going to attempt to solve questions using the completing the square form. Now, if you went through the previous video perfectly, this video is going to be much simplified for you. We're gonna use an example, and that's what we're gonna be solving in a step-by-step manner. So we have an example which is x squared minus 2x minus 2 equals 0. Now step number 1 to solve such a quadratic equation using the completing the square form or method is that you take the constant on the other side. So we have x squared minus 2x minus 2 equals 0. Minus 2 is our constant. We take it on the other side. Hence we have x squared minus 2x equals 2. Alright, so you've taken the constant on the other side and you have a new equation which is x squared minus 2x equals to not a new equation but a rearranged equation, you can say. Then you have step number 2 in which you need to add a number to the left hand side to make the side a perfect square. Now you're going to be using the steps in the previous video to go about this steps in the previous video. So you have an x squared minus 2x equals to 2 on the left hand side. You have x squared minus 2x. Now if you need to make this side of the expression into a perfect square, you know that you need to divide the middle term by 2. 2 divided by 2 is a 1. And then you need to make it into a square bracket and add it. And you know this is identical to the identity a square minus 2ab plus b square. So we can write this as x square minus 2 into x into 1 plus 1 square. And we know that this identity can be written as a minus b the whole thing squared. So we can write this as x minus 1 the whole thing squared. So the left hand side has been converted into an x minus 1 whole square. Now we know that in algebra, whatever happens on the other side, we have to counterbalance it on the other side as well. So in the step number 2, we were adding something that was not present at the outset in step number 2, that was this plus 1 square. We were adding this on the left hand side. So we are bound to add this on the right hand side as well. So in step number 3, we need to write the perfect square form of the left hand side against the constant on the right hand side. So we're gonna first write that the completing the perfect square form is x minus 1 squared, and against the constant on the right hand side, the constant on the right hand side was 2. So we're gonna write 2 over here. And then since there was a 1 square added on the left hand side, we need to add the same on the right hand side to counterbalance that effect. Because we have an equals to in between, equals to means whatever is happening on the left hand side, the same is happening on the right hand side, or vice versa. So because we added a plus 1 square, we're going to add that over here as well, and that simplifies to x minus 1 square equals to 3. So in our step 3, our simplified rearranged equation is x minus 1 the whole thing square equals 3. Now we proceed with step number 4, in which we square root both the sides. So since we have x minus 1 whole thing square equals 3, we're going to square root both of the sides to cancel out the square. So we're going to do that. X minus 1 square, this is being squared. And when we apply square on the other side, whenever we're writing square root by ourselves and it's not being cancelled out, we have to assume that there is a plus and a minus before it. So that's exactly what we're going to do over here. So we have x minus 1 equals plus minus under root of 3, and this have been resolved for step number 4. We're going to proceed with step number 5 now. We need to solve for two values of x. Now we have x minus 1 equals to plus minus 1.732. Now why are we taking a 4SF at this point, whereas your final answer should be in 3 significant figures? The rationale behind that is that we need to make sure to take this value as 4 significant figures, as it will be carried further. Now this value has to be carried further, hence why you are going to take it into 4 significant figures. Now you need to solve separately. X minus 1 equals to positive 1.732 separately, x minus 1 equals to negative 1.732 separately. So x equals to 1.732 plus 1, x is equals to 2.732. This is equals to x equals to minus 1.732 plus 1, and that's equals to x equals to minus 0.732. Now this is already in 3SF, so x is equals to minus 0.732 is one of your answers. And we're going to convert this 4SF into 2SF, and it's going to be 2.73. So two values of x are x is equals to 2.73, x is equals to minus 0.732. And that's how you solve a quadratic equation using the completing the square form. Now we are going to solve quadratic equations using the completing the square form, which do not have 1 as a coefficient of x square, but something other than 1. For example, the question 2x square minus x minus 2 equals 0. Now, in our attempt to solve this question, some of the steps will be identical to the steps that we've already done while solving quadratic equations without a coefficient of without with a 1 as a coefficient of x square, using the completing the square method. Like for example, step number 1 is a similar step in which we need to take the constant on the other side. So we have 2x square minus x minus 2 equals 0. We're going to take 2 on the other side and we are good to go with step number 1. For step number 2, we need to focus on the left hand side, which is 2x square minus x on the left hand side, and we need to make this left hand side into a perfect square. Now this is 2x, we need to take out 2 as common and we're left with x square minus x upon 2 on the inside. And we know that we need to add x square minus x upon 2 plus 1 upon 2, 1 upon 4 whole square, because that is the half of the coefficient of x. Now that is 2 bracket x minus 1 upon 4 whole thing square when converted into the identity. Now please remember that we are adding 1 upon 4 whole square on the left hand side, and this 2 is also going to have an effect. So in step number 3, we need to add 2 bracket 2, which is going to have an effect, and 1 upon 4 square on the right hand side. So our left hand side is already x minus 1 upon 4 whole square, whereas this is our left hand side, whereas our right hand side is going to be, we already had 2 on our right hand side. So to 2, we're going to be adding this. That's 2 whole 1 upon 4 whole thing square. And after simplifying the right hand side, we get 2 plus into 1 upon 16. And then we get 2 plus 1 upon 8. And then when 2 plus 1 upon 8 is simplified, we get a 17 upon 8. So we have a 2 over here. So beg your pardon, forgot to write a 2 over there. So 2 bracket x minus 1 upon 4, the whole thing square, is equal to this being simplified gives you a 17 upon 8 on the right hand side. Step number 4, we're going to simplify our work as much as we can, which means taking 2 on the other side and then solving for x. In step number 4, we're basically going to be solving for different values of x, and from here onwards, our shifting, adding a square, that stuff has been done. We just need to solve it algebraically the way we know how. Now, solving it algebraically, we have to bracket x minus 1 upon 4, the whole thing squared, equals to 17 upon 8. We take 2 on the other side, we have x minus 1 upon 4, the whole thing squared, equals to 17 upon 16. And we take an under root, we have x minus 1 upon 4, the whole thing squared, equals to plus minus under root of 17 upon 16. And when we do 17 upon 16 under root, okay, then we have x minus 1 upon 4 whole square. When we further solve it, x minus 1 upon 4 whole square equals to plus minus 1.031 when we further solve it. After applying the under root, under root cancels, and then you have x minus 1 upon 4 equals to plus minus 1.031. And when we further solve it, we have the value of x as positive 1.28, and we have the value of x as negative 0.78. That's how we solve a quadratic equation using a completing the square form, which does not have 1 as a coefficient.